Hello scientific people. So let's talk about the intensity equation and graph of I versus delta phi. So we are doing a deep analysis on the intensity equation which we have already derived, and we are also going to plot the graph of intensity versus phase difference, right? Okay, now for constructive interference, which means I am talking about the bright fringes, and destructive interference means where the crest and trough meet. So I am talking about dark fringes. Okay, so when we talk about bright fringes, the intensity has to be maximum, and the intensity maximum could be 4i because cos square function has maximum value +1. So intensity would be maximum for bright fringes, and that is 4i, where I is the intensity coming out of one slit. And for destructive interference, I net would be minimum value, and that would be 0 because the minimum value of cos square function is 0. So if I substitute it over here, my intensity would be 0, right? Now let us see this cos square function graph. So this cos square function graph is maximum at 0, pi, 2 pi, 3 pi, 4 pi. That means at n pi we have maximum value of cos square theta, that is +1. So which means that this angle delta phi by 2, if it is equal to n pi, then I will get cos square delta phi by 2 as +1, and then and only then I will get the maximum intensity equation. And if you look at this graph again, at pi by 2, 3 pi by 2, 5 pi by 2, right, then 7 pi by 2. So in short I am talking about 2n minus 1 pi by 2. So if the angle delta phi by 2 is 2n minus 1 pi by 2, then cos square function or the cos square delta phi by 2, that is going to be 0, and then and only then I will get the net intensity or minimum intensity. So now I know what is delta phi. So instead of delta phi, this 2 goes over here. So delta phi is equal to 2n pi, which is the condition for the bright fringes phase difference. So this is the phase difference condition for bright fringes, and from here 2 and 2 getting cancelled. So delta phi is simply 2n minus 1 pi. So this is the condition for the phase difference for the dark fringes or minimum intensity. Now one by one I am going to substitute n is equal to 0 over here, then n is equal to 1, n is equal to 2, and n is equal to 3. I think these readings are enough for us to understand the graph well. And again over here I am making sure that I am starting from n is equal to 1. I can't start from n is equal to 0 because n is equal to 1, n is equal to 0 is reserved only for central bright fringe, which means I have to put n is equal to 0 only in constructive interference. So n is equal to 2, then n is equal to 3. All those values can be substituted, right? And as the lecture proceeds further, you will understand what does this actually mean. So if I put n is equal to 0, I am talking about the central bright fringe, and its phase difference would be 0. Then phase difference would be 2 pi, then phase difference would be 4 pi, then again phase difference would be 6 pi. Now if I put n is equal to 1 over here, I'll get phase difference as pi. Then if I put n is equal to 2, phase difference would be 3 pi. Here phase difference would be 3 to the 6, so I would be getting 5 pi. So now we have enough values to plot the graph, right? So we have 0, then we have pi, then we have 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and in this way it will continue. So now I will substitute the values over here. So delta phi has got 0 value, then pi value, then 2 pi, 3 pi, 4 pi. In the same way I can keep on going till 5 pi, 6 pi, and so on. I can also choose to put minus pi, minus 2 pi, minus 3 pi, minus 4 pi, because anyhow if I put the negative values in here I will get the same answer. So if I put negative pi, then it means that I am talking about this point only, because pi positive or pi negative I am going to get the same answer as 0, right? Okay, so if I put delta phi as 0, I get maximum intensity, because all these fringes are bright fringes and all these fringes have maximum intensity 4 pi. So I will make sure that this point is having intensity 4i. So all of these readings, that means at 0 I am going to get maximum intensity, then at 2 pi, 4 pi, 6 pi. So this is 2 pi value here. Then at 4 pi again I am going to get the maximum value. In the same way at minus 2 pi also I am going to get maximum value, and at minus 4 pi also I am going to get maximum values. And in between, pi minus pi, 3 pi minus 3 pi, 5 pi minus 5 pi. At all these I am going to get 0 intensity, because we are talking about destructive interferences, right? Okay, so I am going to substitute the value over as a pi, 3 pi, then 5 pi, then minus 3 pi, minus pi. So I am ready with my points. Now we know that intensity is a cos square function. So the graph has to actually go like this. So it's a cos square function. Please pardon my drawing if I don't do it nicely over here, like this. And the same way, this is a cos square function which is going to like this one. So this is our intensity versus delta phi graph. Now we will be talking about the path difference, and finally we will be putting down all the fringes over here, right? So a path difference equation we are already aware about. We have already derived this in our previous lectures. Delta x is equal to n lambda, and delta x over here is 2n minus 1 lambda by 2. Now some of the viewers might be confused that I have taken n is equal to 0 over here but not here. So I'll explain it to you now. So if we look at point O, and suppose I am taking out two rays, now these two rays are traveling from S1 and S2, these slits, and these are traveling actually equal distances. So if they are traveling equal distances, when they reach at point 0, when they reach at the center of the screen, the path difference over here would be 0, because they are traveling the same path. So at this point path difference is 0, and I can only obtain path difference 0 over here by putting n is equal to 0. I can't put n is equal to any other number, because n is the order of the fringe. It's a whole number, 0, 1, 2, 3, 4, 5. So I can't get path difference 0 over here. So that's why n is equal to 0 is reserved for bright fringes. So if I put n is equal to 1, then n is equal to 2, n is equal to 3. Again, I can put n is equal to 1 over here, n is equal to 2, n is equal to 3 over here. So I'll get path difference delta x as 1 lambda, 2 lambda, 3 lambda. And over here if I put n is equal to 1, I'll get path difference lambda by 2, then 3 lambda by 2, 5 lambda by 2, and so on. So at n is equal to 0, we have always a central bright fringe. This is the bright fringe. This is n is equal to 1, n is equal to 0. This is the order of the fringe, and the intensity would be 4i, maximum intensity. Path difference is also 0, phase difference is also 0. Correct? Now, just above this one, we have first dark fringe, n is equal to 1, n is equal to 1. So first dark fringe is just above the central bright fringe and below the central bright fringe, where the intensity would be 0, path difference would be lambda by 2, and the phase difference, as we have already discussed, the phase difference would be pi. Now, why we are also getting the fringe at the bottom? Because if you put this as minus pi and minus lambda by 2, because as you go up, R2 would be longer than R1. But as you go down, R1 would also be longer than R2. So it will create a similar kind of situation up and down. Right? So as you go up, you will get first bright fringe, then again first bright fringe. And for first bright fringe, the intensity would be again maximum 4i. Then the path difference would be equal to, here n is equal to 1, so it is lambda, and the phase difference corresponding to this would be 2 pi. Then again you will get the second dark fringe. Again you will get second dark fringe over here. I am not drawing that because that's a dark portion. The intensity would be 0, then path difference would be 3 lambda by 2, then the phase difference would be equal to 3 pi, right? So I think that you might have got it what I want to say over here. In the same way, you can continue for n is equal to 3. Here also, this is the third bright fringe. So again, intensity would be 4i. Then the path difference would be 2 lambda. Then this would be equal to 4 pi, like this. So all these points we have jotted it down, and in this way we get the beautiful pattern of fringes over here. So hopefully guys, you have enjoyed the explanation, and please do subscribe to my channel if you have not done so. Thank you for watching the video.